Hello class 9, let's solve the exercise 7.1 from your end. Question number 1. In quadrilateral ACBD, AC is equals to AD and AB bisects angle A. Show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? So here in the given figure we can clearly see that ACBD is a quadrilateral. Here this side AC is equals to AD and this angle A has been bisected by AB. So since angle A has been bisected, we can say that these two small angles are equal. So CAB is equal to DAB, we can clearly see so. And the side AB is common to both the triangles. That means triangle ABC has the side AB and also the triangle ABD has the side AB. So we can see that this is a common one, that is an equal side. So we can write that in triangle ACBD we have AC equals to AD, which is already given, and AB being the bisector of angle A, we can see that angle CAB is equals to DAB. So there is a pattern how we should write it. So now in triangle ABC and triangle ABD. So with respect to triangle ABC, whatever side will be equal or something, we will write on the left hand side because we have written ABC on the left hand side. And the remaining parts of the other triangle will be written on the right hand side. So the first condition is AC equals to BD. AC lies in ABC, so we have to write it in the left hand side. So AC is equal to AD, right? It is already given. Next, since it is a bisector, then CAB, angle CAB is equals to angle DAB. So we have written right here, and the cos, that is AB is bisecting angle A. And the third one is that AB is a common side. That means AB is an equal side. So we can see that we have talked about a side, then an angle, and then a side. Side, angle, side. Again for this one, side, angle, side. So we can see that by SAS congruence rule, we can say that triangle ABC is congruent to triangle ABD. Now, we have to write the name of this triangle very minutely. Since we have written the name of one of the triangles is ABC, so we have to choose the name of the second one cautiously. So we can see that angle A right over here is equal to this one. So instead of angle A, we will write angle A in the first position. Angle B of triangle ABC right over here is also equal to angle B of this side. Reason, AB is equals to AB. So here also AB will be equal to AB. Next, angle C is equals to angle D. Why? Because AB we have already written and the third vertex is D. So definitely it will be D. So if we choose the first two correctly, the third one will also be equal. Now to check, we have AC equals to AD. So AC is equals to AD. So thus the name is perfect right over here. Now since we can write that these two are now congruent to each other, that means exactly equal to each other. That means angle C is equals to angle D, angle A equals to A and B equals to B. That means can we say that if we flip this one, it will be exactly equal? So therefore we can say that these two sides, already these sides are equal. These two sides are equal, these two sides, this side is equal. The remaining sides are BC and BD, therefore they will also be equal. So they are the corresponding parts of the congruent triangles. Therefore we can write BC is equal to BD by CP, CT, or corresponding parts of congruent triangles. We don't have to write such a long statement. We can just write down CP, CT. Question number 2 says, ABCD is a quadrilateral in which AD is equals to BC. So here is a quadrilateral where AD is given equal to BC. And angle DAB is equal to angle CBA. Angle DAB is right over here. This full angle is equal to CBA, this full angle. Prove that triangle ABD is congruent to triangle BAC. Triangle ABD, this triangle is congruent to BAC, this. So from the diagram what we can see that in triangle ABD, this triangle, right? Here AD is equals to BC. Again for ABD and BAC, we can see AB is a common side. And in this triangle, angle A is equal to angle B of this triangle, right? So we can see side, angle, side. And again here for this triangle ABC, side, angle and side. So we can say from the diagram only that by SAS rule they are congruent. Let's see. In quadrilateral ACBD, we have AD equals to BC and DAB is equals to angle CBA. We should always write down whatever is being provided in the question. Next, in triangle ABC and BAC, AD equals to BC, already given. Then DAB is equals to CBA, this is also given. And AB equals to AB, which is the common side. So therefore, we can say that ABD is congruent to triangle BAC by SAS congruence rule. Next, we have to prove that BD is equals to AC. Now, we have already proven this triangle is congruent to this one, right? So, this side is equals to this side. This is a common side. So, remaining sides are this one and this one. So, therefore, by CPCT, we can clearly see that AC equals to BD. And the third part says that angle ABD will be equal to BAC. So, ABD, this angle ABD will be equal to BAC, that is right over here, a small triangle. So for this one, what we can say that since ABD is congruent to BAC, therefore here we can say angle ABD is equal to BAC. So if we choose these two triangles, this and this, so for this triangle, this is the corner side, and for this triangle, this is the corner side. So when we are talking about angle ABD, this actually lies in the triangle BAC. ABD lies in triangle ABD, and BAC lies in triangle BAC. So therefore, by CPCT only we can say that they are congruent. Question number 3. AC and BD are equal perpendiculars to a line segment AB. Show that CD bisects AB. So when they AC and AD and BC are equal perpendiculars, that means they are equal in size and they are also perpendicular to a line segment AB. That means AD is perpendicular to AB and BC is also perpendicular to AB. That means this angle is 90 degree and this angle is also 90 degree. We have to show that CD bisects AB. So this is the line CD and we have to show that this line is bisecting or dividing into equal parts the line AB. That means they are meeting at a point O, right? CD is meeting AB at O. That means at O it is bisecting the line AB. That means we have to prove that OA equals to OB. So what we can do right here is we can take triangle BOC, this, and triangle AOD. Okay. So we already know that angle B right here is equals to angle A because it is 90 degree. Again it is given that BC is equals to AD. And the third one can be written as angle BOC is equals to AOD. See, these two angles are vertically opposite because AB and CD are two straight lines and they are intersecting at O. So they are having vertically opposite angles. So these two angles are equal. So what we can see is this angle is equal to this angle is equal to this, and the side which is not in between them but any other side is equal. So two angles are equal, corresponding angles are equal, and any other corresponding side is equal. So therefore, we can say by AAS congruence rule, triangle OBC is congruent to triangle OAD. Again, we have to be careful about the name. So BC equals to AD. So BC equals to AD. And we know angle AO is equal, right? So instead of angle O. So therefore we can say they are congruent to each other. So the next part says that we have to show that they are bisecting. Now if they are congruent to each other, therefore their corresponding sides are also equal. So from here, can we say that OB is equals to OA, right? So from this side, we can say this name. So from the names also, we can tell the name of the corresponding sides, right? So from here, OB first two is equals to OA, the first two, right? So OB is equals to OA, OB is equals to OA by CP, CT corresponding parts of corresponding triangles or congruent triangles. Now, since we can see that in a straight line AB, if O is in such a point so that OA equals to OB, that means O must be the midpoint, right? So we can also conclude from here that O is the midpoint of AB. If O is the midpoint, therefore CD is actually bisecting AB at O. Right? Question number 4. L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is equal to triangle CDA. So here are two lines. These two lines are parallel to each other, L and M, and here P and Q are also parallel to each other. Now these two sets of parallel lines are intersecting at few points A, D, C, B, right? So they are intersecting. Now they have formed a quadrilateral in between. See, ADCB is a quadrilateral here, or we can also say they are parallelogram. Why so? Because see, AB and CD are parallel because of P and Q, and AD and BC are also parallel because of L and M, right? These two are parallel sides, these two are parallel sides. So opposite sides are parallel to each other and they are also equal. Therefore, it's a parallelogram, definitely. Now we have to show that triangle ABC is equal to triangle CDA. ABC, that is this triangle, is equals to CDA, this triangle. So they will be congruent or equal. And it must be congruent here. Since P is parallel to Q and AC is the transversal, right? These two are parallel. P and Q are parallel and AC is the transversal. Can we say that angle BAC, this angle, is equals to DCA, this angle? These two are alternate to each other, right? Similarly, if we take L and N, we can also say that L and N are parallel and AC is the transversal. Therefore, we can say VCA, this one, is equals to DCA. These two are also congruent, alternate to each other. These two are alternate and equal. These two are alternate and equal. So we are having two angles which are equal. See, this is a triangle, this is a triangle. These two angles are equal, these two angles are equal. And this is a common side, right? AC is a common side. So A, S, A. Again, A, S, A. So by ASA, we can simply prove that they are congruent. So we'll just write down the relations here. And we can write down by ASA congruence rule, they are congruent. Number 5, line L is a bisector of an angle A and B is any point on L. So we have a line here. Okay. So line L is the bisector of angle A. So we have angle A right over here and angle L or line L is actually bisecting it. That means these two small angles are actually equal because angle A has been bisected. Again, B is any point on L. This is any particular random point on L. BP and BQ are perpendicular from P. So now these are the arms. Okay, AP and AQ are the arms of the angle A. From point P or from point B, they have dropped a perpendicular on P, and from point B, they have again dropped a perpendicular on the other arm at Q. So these two are 90 degree, angle P and angle Q are 90. Show that triangle APB is congruent to triangle AQB. So this is APB and this is AQB. We have to show these two are congruent to each other. So clearly from the diagram, we can see that we are having right angles. Now, since we have learned about RHS, right, in the previous video, we can say that we can use the RHS rule here. But for that, we must know whether the hypotenuse is equal or not. So we can see that we have right angle triangles, fine. Then we have the hypotenuse, because the hypotenuse for this triangle is AB and the hypotenuse for this triangle is opposite to 90, that is AB. So the hypotenuse is also equal, but we do not have any equal side. Neither we know that BP is equals to BQ or not, or we do not know AP is equals to AQ or not. So for RHS, we need right angle, then hypotenuse equal, and also any one side which is equal. But we are not getting the other side which are equal in the two triangles. Therefore, we cannot use the RHS rule here. So, what to use? We can have here are two angles which are equal in the two triangles. Again, another two triangles are, angles are equal here. And we have a common angle. But these angles are not having the angle or the side between them which are equal. See, AP is not equal to AQ, which are the sides between the angles. So we cannot use the ASA. ASA is not valid here. But we are having any two angles and any one side which is equal. So clearly we can use the AAS rule. Any two angles and one side. So as L is the bisector of QAP, therefore we can say that QAB is equals to PAB, right? These two angles are equal. Then angle Q is equals to angle P, because each of them are 90 degree. Therefore we can say ABQ is equals to ABP, ABQ is equals to ABP, right? By angle sum property, or we can directly use angle Q is equals to angle P also. Now we are having two angles which are equal, and the third side is also equal, but we need ASA, right? So AB is the common side, so we can write down all of them, and hence we can say by ASA congruency rule they are congruent. And as because they are congruent, for the second part of the question, the first part was this, and the second part said we have to prove BP is equals to BQ, or B is equidistant from the arm of angle A. So since they are congruent, these two triangles are congruent, therefore they are exactly equal to each other. So if these two angles are equal, these two angles are equal, so we can clearly flip this here, right? We can say AP is equals to AQ and BP is equals to BQ, right? Or from the name also we can find out. See, AP first two is equals to AQ, the first two, and PB, the second two, is equals to QB, the second two. So we can get the name from here as well. So we are getting BP is equals to BQ by CBSE. Therefore, perpendicular distance from AP is equals to perpendicular distance of B from AQ. Thus, the point B is equidistant from the arm of angle A. Hope everyone could understand all these sums properly. Hope the session was helpful to everyone. Thank you for watching the video. Bye bye.